This exercise is going to be a two-part exercise where I demonstrate the usefulness of nested functions and lexical scoping. In the first part of the exercise, we're going to implement an algorithm for Newton's method for finding the square root of a number. And we're going to do that by creating several functions and then use those together to find the square root of a number. Then I'm going to demonstrate how to use nested functions to build the same result in one function definition where we have multiple functions defined inside one. So let's get started with part one of the exercise. So we're going to call this program chap13ex1.py. So the first thing we need to do is import the math library because we're going to use a function from that library, fabs, for finding the absolute value of a number here in just a minute. So the first thing we're going to do is define a square function, a very simple function that simply squares a number. Now we'll begin our square root definition. So we're going to call it sqrt, and we will immediately call what we're going to term a helper function, square root helper, with a couple of parameters. We'll explain those here in just a minute. Square root helper is where we do most of the work of the function. I'm going to explain how Newton's method works as I go through the definition of these functions. So the first thing we do is we're going to provide a guess at what the square root of the number is, and then we're going to see if that guess is close enough to the actual root. And we're going to do that by defining a tolerance or a threshold for how close the guess can be. You'll see how that works in just a moment. So if we're close enough on our guess, then we're going to return the guess. Otherwise, we're going to recursively call the function again with a new guess that's improved and the number that we're trying to find the square root of. So the next thing we have to do is define our close enough function. And here's where we look at the threshold. So we call the absolute value function f absolute value. It stands for floating point absolute value. And to do that, we square the guess minus the number we're looking for to see if that's within a tolerance or a threshold of 0.001. And we're saying if we're within that difference between our guess and the number we're trying to find the square root of, then we've come close enough. And so then to improve our guess, we're going to return the average of the guess and the second argument, x, divided by the guess. You'll see how that works in a minute. And then we define average of x and y to take the sum of x and y divided by 2, which of course is the average. So these are the different functions that make up our Newton's method algorithm. And we can test it on a very simple square root problem, the square root of 9. So let's save, then call our program. And so there you see how close we got to the actual value. Let's call it up again. Let's try a different square root. And now let's try it again. Okay, so let's bring the code back up. Here's a set of functions that together will implement the Newton's method algorithm. So in the next part of this exercise, what we're going to do is we're going to see how we can put most of these definitions inside one function using nested functions and lexical scoping so that we have a more compact and efficient function definition. And we're going to immediately see how to do that here in part 2, which is coming up next.